All right, welcome everyone. We'll get started with the session here today. Thank you all for coming. We're going to talk about persistent identifiers, use cases, and PID types. And I'm Matt Mernick from NCAR, and I'm going to go through a few slides here. But first, I want to thank Diana Ma, who's online, and Mark Parsons, who's here, who we'll hear from shortly, as co-organizers. We got a couple great speakers that we'll get to in a few minutes. So this session is coming out of the ESIP Citation Cluster, which I think Mark will say more about, so I'm not going to say a whole lot, but which is a cluster under the Data Stewardship Committee. Okay, so what is a persistent identifier? There are lots of definitions. I just grabbed two that I like and that are pretty similar, which is good. Hopefully you can sort of read those, but persistent identifier, it's usually used in the context of digital objects that are accessible over the internet. Typical such an identifier is not only persistent, but also actionable. And the second one, which is from a recent US government document, a digital identifier that is globally unique, persistent, machine resolvable, processable, and has an associated metadata schema. Right, so the idea of persistent identifiers is that they generally are sort of have a web component to them, right? There's some aspect of resolving onto something online, and you know they do something for you. There's some actionability. So it's kind of to make a distinction between a persistent identifier and just say the identifier right here next to this article. That's not a persistent identifier, it's simply an identifier.
Sorry to interrupt. There's a notes document linked off the SCED page. We'd love you all to sign in.
Yeah, thanks.
And it also has links to all these slides and stuff.
So that's what we're going to talk about are things like DOIs, but what we're interested in is also going beyond talking beyond DOIs and understanding the landscape a little bit around this concept of these persistent identifiers. Okay, so this is a figure from Mark. He's got a recent essay where you can kind of go to there, which talks about a lot of things related to PIDs, and I think this is a great figure to sort of frame. There's lots of different challenges. Mark, do you want to say anything about this?
So Gaipeng is leading an effort to develop FAIR guidance for the NASA DACs. And identifiers, of course, are central to FAIR. So I ended up writing this essay just of thoughts that I've had over the last few years. It's kind of meta, but Matt says I'm kind of meta. But the point is, and something that I just think we need to keep in mind, is that identifiers have multiple purposes. They identify, which object is in question, which is very critical for a machine to understand in particular. Where it is, or how you access it, where is maybe a fuzzy concept in the world of cloud, but how you access it. In many cases, it tries to indicate what sort of thing it is. That's what the resource type field is for in the DOI metadata. And my argument in the essay is that those are actually interrelated and rather fraught concepts. And they really depend on the context that you're looking at. And they're often used as proxies for each other. Which thing is often conflated with where it is. And sometimes where it is gives you a hint as to what sort of thing it is. So we could go off on a big can of worms, but I won't do that. But if you're interested, please take a look at that essay, and I would welcome your comments.
Thanks, Mark. So in this talk, we're definitely not going to be able to address all the issues. We're going to focus on a few, but we just wanted to note that there are still a lot of challenges, which I think is why we're all here, and we're doing a session on this today. So the landscape is big and growing. The stuff in the middle is just sort of a cartoon. Don't take the locations of any of those things too seriously. But just to indicate that there's PIDs being assigned to many different types of things, and in somewhat of an arbitrary fashion. There's a whole ecosystem of PID providers or systems. The ones on the right tend to be ones that are assigned to a certain type of thing, like research organization registry, is that right for RORs? Which is an organization identifier. Orchids, of course, for people. IGSN is geosamples. RAID is something I learned about recently, but which is about research activities and projects. And then there's a bunch of types of IDs that are shown here on the left that are assigned to lots of different types of things, including DOIs, as we know, RIDs, research resource IDs, which tend to be used more in the biomedical community, and then ARCs, and John Kunze is here. He'll talk more about ARCs this afternoon. There's also flavors of these, right? The data site DOIs and Crossref DOIs, and actually IGSNs are now a flavor of DOIs. They have differences in terms of metadata and other things, even if the resolver is the same. So there's a big ecosystem. It's still growing, and kind of hard to know which direction it is growing. So what we wanted to do with this session is kind of talk about kind of three things, and we'll see how organized these discussions are, but there's the considerations around what type of thing you're identifying, sort of the stuff in the middle. There's considerations around the use cases, which Mark mentioned. There's different reasons for assigning identifiers, which we'll get into. And then there's considerations of what identifier system to use. So those are the kind of the three things that we're talking about in this session. The immediate motivation for me, I'll just mention how this came about, is that the PI of a recently funded NSF project, Research Coordination Network on PIDs for facilities and instruments. We've assigned some DOIs at NCAR to some facilities, and we've got now a number of collaborators who've used other identifier schemes for the same purpose. And so we're trying in this project to kind of get at, why would you use a given identifier scheme for this reason, or for different reasons related to facilities and instruments. So as a bit of self-promotion, if you're interested in this topic specifically for facilities and instruments, we have a workshop coming up in September, which we have travel money for, if that's possible, where we're going to dig into this in detail. So I invite you to that. In this session, we're going to talk much more broadly. We're not just focusing on any one type. We're really looking at kind of these questions broadly for lots of different resource types. So if you're interested in this, you can talk to me or check out this website. We'll be happy to have you talk about instruments and facilities in September. Something I just learned about yesterday, which would have potentially informed the organization of this session had I been aware of it earlier, and thanks to John Kunze for pointing this out. I won't attempt to pronounce this website name, but it's Dutch. So they have a nice persistent identifier guide, which actually has a pretty good tool for walking through a bunch of these considerations that I think we'll also talk about today, and giving you sort of, according to their rubric, guidance as to what type of identifier to use. So I walked through this actually just yesterday quickly for my use case around persistent identifiers for facilities and instruments, and this was the recommendation, which was to use dataset DOIs, which we're doing at NCAR, so I felt pretty good about that. But they only have these 4 types, and as I showed on the previous slide, there are others. So I think this doesn't solve all the problems, but this is a good resource that if this is a question, what ID type to use for what purpose, for what resource type, this could be useful for you to take a look at as well. And it may be worth ESIP, as we get into this, to potentially talk to these folks and partner with them a little bit. Okay, so that's PIDs kind of in the background. I think what we want to get to here is really talking about using persistent identifiers. Here's another quote that I like. In order for scholars to benefit from the use of persistent identifiers, there needs to be a clear case made to them about the benefits of taking time to do so. So that's where we're really going to focus on use cases in the breakout sections, which we'll get to in the second half of this session. We want to hear and get your input on which use cases are most important for this community for why PIDs are being used. What I mean by use cases, this is a very simplistic example, but these are the kinds of things we want to get into discussion. So 2 use cases that are very common is credit, right? So assigning a DOI, for example, to ensure proper credit is given to authors and contributors of a data set, a software package, or an instrument. That's one use case, whereas getting the artifact, and this gets back to Mark's point about sometimes these are conflated and we use the same technologies to do them. But they are different use cases in the sense that for credit, you really need to have potentially some kind of fairly high fidelity of metadata. Who are the people, right? So you can give them credit. What is the resource? So you can give credit for that thing, maybe even what type it is, what years, those kinds of things. You can give credit for something without actually being able to access it, right? I do citations for things that I can't access. Maybe that's bad scholarly practice, but I can hear about them. I hear about them through other resources, right? So one thing cites one thing cites another, and I can cite that thing that was cited from 1895, even if I don't have access to it. Whereas in the case of access, you may not need any metadata at all. You just want to get the thing, and nothing beyond the location, as Mark said earlier, is necessary. So that's kind of 2 use cases, and there's many others which we'll get into. Okay, so this is the session structure introduction, which I'm finishing here. We're going to have 3 presentations from Ted, Matt, and Dan Katz, who's online. They're all going to touch on some aspect of those three things, right? What type of resource are we talking about? Use cases, and different PID systems. They won't necessarily all talk about all of them, but the intention is that they will be sort of thought starters to kind of get you thinking about those things and lead into the second half of the session, which is going to be some guided discussions. Mark will give a little more context after these talks, and we'll kind of dig into these questions, right? What PIDs should I use for a particular purpose? What use cases apply to different types? And what capabilities do the different PID systems provide? And how do those relate to the use cases? So with that, I will stop and we will get Ted queued up here.
Any questions while we're transitioning? Okay.
Thanks, Matt. Good morning, everybody. So I was going to talk about the sort of address or take a look at the use case problem and of how identifiers are being used in ESIP and in other places. And I wanted to sort of simplify sort of my simple picture of the identifier landscape and just mention three. First, RORs. Matt said the research organization registry. This is a registry of roughly 110,000 organization names with identifiers. It originated from...
In the event that you can hear me, we're seeing presenter mode. Okay, sorry, somebody's fixing that.
And you'll know that I don't have any notes. I'm just making this all up. Anyway, ROR started from a company named Digital Science, who has something called Dimensions, and they had something called a GRID, a Global Research Identifier, and that was the sort of minimal viable product that was given to, it contributed to ROR, and ROR has grown from there. Okay. Now we want to try this one. How about this one? Oh, yeah, okay, sorry.
That's okay, very good.
Orchids for people, the second identifier. This one, Matt also mentioned these, of course. And then, so these are the things we use for people and organizations, and then everything else we use DOIs. And Matt mentioned there's a couple of different metadata models that underlie DOIs. Crossref generally used for journals and books, DataCite used for pretty much everything else. And of course, Orchids and DOIs are both they're both instances of handles. So handles is really the underlying identifier system that a lot of these use. ROR does not. DataCite has existed for roughly 12 years or so, and during that time, the resource types that DataCite supports have grown a little bit. This is the current list of resource types that DataCite supports, and we can. So this is why I said everything else goes in DataCite. Orchid is people. Crossref is really books and journals. DataCite is everything else. And the history of DataCite looks like this. So this is a stacked bar showing the resource types that have existed in DataCite through time. Someone yesterday was talking about DataCite starting out as sort of being a data set thing. And so people were using DataCite for getting DOIs for data sets. And then later on, it expanded to include text. And text was sort of a generic title for a number of different things. So in version 4.3, I think the next to last version, we added a number of sort of subtypes of text. And I did this picture a year ago and wrote a blog about it because I was interested in how we were thinking about DataCite like for data sets, but it's also really much broader. And on Monday, I decided I should update this picture, so I drew it this way. I included 2023, which is on the end here. And you can see what's interesting about something that happened in DataCite is that during this year, there have been almost 10 million samples added to DataCite. Matt mentioned that IGSN is using DataCite now as their infrastructure. And so most of these 10 million are IGSNs, what previously IGSNs that have now been inserted into the DataCite infrastructure. So this is a big change. And of course, many people in ESIP have been involved in making this, building that foundation for IGSNs, and also in the decision to move their infrastructure into DataCite. So this sort of it was a big surprise for me. In fact, I had to like redo it a few times to make sure that I wasn't making a mistake. But this is a fundamental change in DataCite, and it's going to be very interesting to see how it develops. And whereas Leslie, I think is here. Yeah, Leslie in Australia is contributed 4 million. I mean, Leslie's a very fast typer, and yeah, it's actually 4.3 million, but that's okay. 3 or 4 or 5 million, you know, once it, yeah, okay, we can talk about that. But anyway, it doesn't matter. It's, you know, it's a big pile of samples that are now in DataCite, and, you know, a bunch of millions, and many others came from CSAR, who many of us are familiar with from Columbia. So that's why I said I didn't need to do that. Not this. These computers are so interesting, these Windows things. But anyway, so that was all I really wanted to say about RORs, or about DataCite and what's in DataCite. We mentioned yesterday, we heard about Funding Friday, and a couple of years ago, 2019, I got a Funding Friday project to work on identifying ESIP connections. And what we did was took various lists of affiliations of people that had attended ESIP meetings, and we used those affiliations to then search for RORs and extract the organization names from them. And this is the typical approach that we use to assign RORs, to find RORs from affiliation strings. And something I did also for Dryad with 20,000 data sets. But so we did this for ESIP, and there's 3 pages on the ESIP wiki that give lists of members of ESIP, participants in ESIP, and ESIP sponsors, and their RORs. So if you're interested, you can take a look at the ESIP wiki and find a ROR for yourself, your organization, and for other members of ESIP. And there's a link to that here. And of course, you can also use the roar.org to search for your organization, and that's sort of like the up-to-date stuff. But there are many members of ESIP, and participants have RORs. One of the interesting questions in ROR land is always, what about a hierarchy? And hierarchies are important. We all know that NASA and NOAA and US Geological Survey and other organizations that were involved with universities have a lot of departments or various parts. And this is a typical, not a typical, but an example of an ESIP affiliation that has a lot of different organizations in it. In this case, one is Ceres, and one is, I don't have my glasses on here, but I think one is Ceres, and one is NSIDC, and one is NASA, or the University of Colorado and NASA and Ceres. And this is one of the problems that we have, and when we're doing this, what we call recuration of looking at affiliation strings, say in papers, and trying to find RORs. On the far right column of this is a hint about how we found this, and notice that NASA doesn't actually exist in this affiliation string, but I happen to know NSIDC, of course, and so I, as a curator, added the ROR for NASA to this. And when the question comes up about hierarchies, my tendency is, put in all the levels that you can find, so that people can find. If they search for NASA, they find you. If they search for University of Colorado, they find you. And if they search for Ceres, they find you. You can, all the metadata models that have identifiers allow multiple identifiers. Amanda French at ROAR, she's the technical community lead, just wrote a blog post about this, about parents and children in relationships in DataCite or in ROAR. And so this is a great resource for Amanda and ROAR's thoughts. And the ROAR DataCite, the ROAR website now allows you to see the parents and the children of whatever organization you're looking for. And this happens to be the page, and I'm sorry I had to make it so small, but NOAA has so many children that it had a long list. In this case, there are 69 different children of the NOAA ROAR. So this is sort of a new feature that's available on the ROAR DataCite, on the ROAR website. There's too many of these words that are similar. Okay, so that's it for ROARs. Now I wanted to talk about Orchids for a little bit, and just to make sure that we understand, Orchids, there's two ways that you can say this word, and the right way is the right way is orchid, and the wrong way is orchid, okay? Because none of you are orcs, as far as I know. All of you have orchids, I'm sure. So thinking about orchids as IDs for orcs is not a great idea. Think about it as some wonderful flower that has a lot of diversity and that we can use. So anyway, this is what an orchid page looks like. This happens to be the top of mine. The big benefit of Orchid is that you can use it to collect links about yourself, make a little graph of things that you've done. And the nice thing about, the important thing about Orchids is once you get them, you want to make your information in Orchid publicly available. If you have an Orchid, many people have Orchids without having publicly available data, metadata basically, so you can find out their name, but you can't find out anything about who they are or what they've done. And when you're looking at 5,000 or 10,000 orchids and trying to figure out, or for one name you might get 20 orchids and you're trying to figure out which one of those is the right person, you really need to be able to get to that public open information. So you can attach many different things to your Orchid profile, and this just shows some employment, works, et cetera, and we'll get to that in just a second. So how do ESIP members use Orchids? The vast majority, so this is a histogram or a donut that shows the number of things that are included in ESIP Orchids. So I had a pile of 139 ESIP Orchids, and we can see that the vast majority of the stuff that's in there is works, which is publications, stuff like that. 1 minute, cool. And this is an important thing actually inspired by Matt. He asked this question, who's putting this information in there? So in these, we can see that the vast majority of information in Orchid profiles comes from journals that publish papers and things like that. And you have to give them permission to make these connections for you, but then they can do it. And that's the same was true in a sample from UCAR. So what other kinds of things can we get credit for? ESIP is a wonderful big community, and a lot of us make a lot of contributions to ESIP for different kinds of things, meetings, presentations, clusters. We saw everybody standing up yesterday was great. And I just wanted to throw this out there as an idea that's out there that you might want to be aware of. Here we can see a page from a tool called ResCognito, and this is mine. And there happens to be things on there like committee work, conference session, organization, conference poster, conference presentation. And these are things that members of participants in ESIP do that are significant contributions to ESIP. And ResCognito's idea, Richard Wynn's idea, was to collect these things and to allow the community to specify them so the community can specify it. And Aaron Robinson and I worked on this a few years ago, and we did this. We compiled contributions that have been made to ESIP by a wide variety of people, and this is the list of the people that had the most. These are called COGs. So you can see Ruth and Bob Downs and Douglas Carl, many people that we know who have made many kinds of interesting contributions to ESIP. And it's built on RORs and IDs. So anyway, it's all about connections. This is a picture of some ideas about project metadata. We have IDs for people, we have RORs for organizations and funders, and then we have DOIs for everything else. Thank you.
All right, thanks, Ted. For the sake of time, we're going to move on, but hopefully that's got some ideas there. Oops, I may have stopped screen sharing, so we have to get that going again. Are we still sharing screen on Zoom, folks? No?
Nope.
All right.
Okay, thanks everybody. I'm Matt Jones from Data One in UC Santa Barbara. I'm going to talk a little bit today about content-based identifiers for Earth observations data and sort of think about a slightly different set of use cases than what was introduced earlier. These are more around the data access use case than the credit use case. And like everybody, I'm going to struggle with the, yeah. So the types of identifiers that have been talked about so far are largely authority-based identifiers, where you have some sort of issuing authority like the DOI Foundation or ROR, and they assign an identifier to some sort of a digital or other object, and that basically stands in or can be used as a way to reference that object. These have a number of really useful cases, like they're curated and they're very widely well known. You know what types of things to assign them to, like Ted described, but they also have some challenges. So they're assigned identifiers. That makes them somewhat arbitrary. There's no inherent link between the identifier and the content that is associated with that. They're resolvable, which makes it so that you can find what you're looking for, but they can also point at mutable content. So that means that if you have a digital object identifier and I access it in 2023, there's really no guarantee that if I access the content behind that in 2025 that I'm going to get the same information. And there's no universal link to data. Like I think everybody probably has tried to find, for example, the actual data files associated with the DOI and realize that sometimes that's challenging. And that's because there's no universal way to make those linkages that's inherent in the standard. So today I'm going to talk about a different model, which are content-based identifiers, where some of these properties are different. So in content-based identifiers, the identifier is inherent in the content. You could never have a different content-based identifier for the same content on two different systems. And that makes them inherently algorithmic and resolvable because you always can tell what the identifier for a piece of content will be no matter where you find it on the internet. So we use these all the time. I think as information technology professionals, we're constantly using systems like Git, Software Heritage, and BitTorrent. If any of you like to watch movies, you'll find that these are all systems based on content-based identifiers. And it's a fundamental approach that's used in distributed information systems. So they have some really nice characteristics. And in the case of content-based identifiers, they do point at immutable content. So how does this all work? Pretty much all content-based identifier systems are based on some form of a hash function. And what that means is that it's a function that takes a set of input information, for example, the content of the data in a data file, and produces a fixed length representation of that that's guaranteed or not, it's probabilistically unique for a certain sort of space. So in the case of, for example, SHA-1 or SHA-256, these are common hashing algorithms that are used in cryptography. These are the sort of basis for all the sort of internet security that we use. And they allow us to produce, for example, a 256-bit string that represents many, many billions of different objects that could be produced in the world. So we can take a file as input and say, I want to calculate the SHA-256 hash for that file. It generates a unique identifier, and it doesn't matter what system I'm on, whether I calculate it on my local system, or if somebody calculates it on some server at a repository, you're going to get the same SHA-256 hash for a data set or for a data file if the two objects are identical. And if they aren't identical, then you're going to get a different hash all the time, every time. And so because of that, there's some really nice characteristics. And one is that if you cite a piece of data that's associated with, for example, an article, then you can tell, for example, if I were to retrieve that data from a website later, whether or not that data has changed or not. So Elliot and Poland and Fortes wrote a paper just a couple of weeks ago that I thought was great. It sort of extols the benefits of using content identifiers as ways to signal authenticity in the data that's used for particular scientific outcomes. They give the example here of this picture of an invertebrate that's in the Museum of Comparative Zoology at Harvard that was accessed on a certain date and has a certain checksum. That checksum I repeated down here at the bottom, so you can see it's a very long number. But one of the nice things about these checksums is that they're sort of a little bit malleable. So you can truncate a checksum and make it shorter and still have a very high probability of getting the same unique value. So because these things are so long and there's so much potential for describing so many objects, you can get quite short checksums that actually describe the same content. And you'll see this used in things like GitHub, where people produce, they will cite short SHA values for their GitHub repositories, when in fact those represent a much larger, usually 64-bit or 256-bit number. So how can we use these for content discovery and access? So one way we can use them is to have repositories that hold content, whether that's individual websites or more official archives. We can have them register the fact that they hold a piece of content based on a URL that generates a hash so that I know, for example, that the KNB might have a data file that's of a certain URL. The Environmental Data Initiative might have the copy of that same data file on their systems, and then I might have a copy of that on my local computer. All of those have the exact same hash. And I can use that sort of information, the metadata about the hash, as a way to determine whether or not I need to go and get a particular piece of content to run some code. So there's really, large number of data sets and a much larger number of digital objects associated with those data sets in networks like Data One. So 840,000 data sets, but billions of data files that are represented in these kinds of data networks. And we've been working to make it so that all of the data files that are registered in Data One are accessible via the content hashes that are associated with those. So you can do a lookup on Data One for content hash and find the current locations of all of the files that are in the network. So for example, this is a data set from the Environmental Data Initiative. It's a Sacramento Bay Delta data set on the tidal slough, and it has 4 individual data files that are associated with the data set. It has the DOI that I have up to the right. Given the DOI alone, I can't really find the data files. And if I were to try to reference that data in, say, an R script that I wanted to run via the DOI, there'd be no universal mechanism for me to tell like which particular data file I'm trying to get to. But instead, I can use a content ID for each of the individual data files. So I could write some R code that uses the content ID package that Carl Bettiger wrote to resolve the multiple different locations that a given data file from this data package might exist, to cache a copy of that on my local machine, and then to be able to run that. One of the really nice things about content-based identifiers is that you can generate a content-based identifier long before the data set is published. So as soon as you have the data, you know what the content ID is. So I can write R scripts or Python scripts that use and refer to data files by their content ID long before they're ever issued, because it doesn't depend upon an authority to actually issue that. So I can write my R script to be working locally with a file for months or years before that makes its way into a repository. When it makes it there, that repository will have the exact same identifier that I used when I was processing the data as I went. So we wrote a pretty terse, but I think helpful tutorial on how to practically use content-based identifiers for reproducible data access that you might find of interest. And I want to sort of end with one final example using content ID. This is the Vostok ice core data set, which is a really famous climate change data set that's been around for many years. There's a lot of copies of it around on the web. And it's a really interesting example where you have the same data that can be found in many different locations. If I have a copy of that data set, I can use Content ID to, quote, store that in my local cache, and that generates the identifier so that I know what it is for my local cache, and I can use that as references in my scripts and programs. I can also call the Content ID sources function to resolve a given content identifier, like this one for Vostok, and find out that not only do I have a copy locally, there's also a copy on Zenodo buried deep in some data package that I didn't know about. And there's a copy on ESSDive, the Department of Energy's data repository. There are actually hundreds of other locations where this data file exists on the internet, but this is easily discoverable through the Content ID package. And then I can use the resolve function to give an identifier, cache a local copy of it, and use it in my scripts. So it's really quite convenient to use these. It's really, you can use a content-based identifier anywhere that you can usually use a URL. So content-based identifiers, in summary, are portable, persistent, reproducible, and transparent. We really want to be able to use the same ID on multiple different systems, even before publication. We want to make sure that they are, there it is. We want to make sure that different repositories and locations will use the same identifier, that when we get some content from a repository that says that it advertises that it's a certain thing, we want to make sure that it is actually that thing, because things do change over time. And then transparent in the sense that references to data in code can easily be traced by their identifier to the actual data set that's associated with them. So there's a bit of future work. Links to DOIs for citation are a little bit challenging. Content identifiers for data packages, like collections of data, are very possible through directed graphs, and that's what Git and other groups use. But I don't think we've really come to a consensus on how to do that within this world for data sets. And then registering content hashes for discovery is still a work in process. So building indices that people can really find these through. But with all of that work, I think content identifiers can be a really important and useful part of the puzzle. And thanks in particular to Carl Bettiger and Jarrett Poland, who've been discussing this stuff with me for the last couple of years and really have influenced pretty much all of my thinking on this. So thanks.
Okay, we're going to do a screen share transition. So does anybody have a question they would want to ask Matt while we're doing that? Oh yeah, go ahead.
So from Tim van der Stap, said, interesting presentation. Thank you, Matt. So would these concept IDs be useful for specific dataset versions released and hosted on GitHub as a substitute for a version-specific DOI?
Yeah, certainly. And one example I gave in the beginning, the software heritage, really does that. So they will archive a GitHub repository using the content identifiers from GitHub and make sure that those are long-term persistent and can be referenced. So yeah, this is very much both possible and already being done. Yep.
All right, thanks for that question. We'll move to our third talk, which is Dan Katz. And so Matt gave a great example of, I think, Matt and Ted, the differences between just the access and the sort of credit use case. And what Dan's going to talk about is other use cases, including related to software and specific. So go ahead, Dan. We see your screen.
Okay, thanks. And you can hear me as well?
Yep, sounds good.
Okay, very good. Yeah, so I'm going to talk about software. This actually kind of has some relation to what Matt was talking about. We probably should have coordinated a little better, but you'll see some connections here. So yeah, and so I should start off by saying that this is really based on work that was done by a joint RDA Force 11 software source code identification working group that I was a co-chair of, but in practice, Moran was really the person that did almost all of the work here, and the co-chairs were kind of honorary in some sense. And this led to this RDA output, which is a report, and most of the slides I'm going to use are actually kind of taken from there. And they're also borrowing from talks that Moran and I have used in the past for discussing that work. So one of the challenges with software is, what is software when we say that, and what do we actually want to identify? And the issue is that there's lots of different things. There's the project itself, something like, let's say, Matplotlib. There's versions, like version 2.0. There's modules within that, then there can be submodules and snapshots and releases and commits and directories and files and code fragments. And so there's a lot of different kinds of things that you may want to identify. If you know those, then there's also questions about the software artifact itself. The thing that you're identifying may be an executable, it may be source code, it may be some kind of a dynamic artifact, it could be an archived copy, it could be a snapshot, it could be a release, so forth. There's issues here as well. And then there's the complexity of software, that it is not just the code, but there's also other stuff. So there could be things like the software environment that you need to actually build the code, things about dependencies, things like tutorials or issues that are in GitHub, or notebooks, or data, input data that you maybe want to run as a test, the output that you should get, articles, documentation. So again, you could think of an identifier for all of this, or you could think of an identifier for different pieces, and that makes this a challenging problem. There's different use cases as well, and I'm not going to talk about all of them here. This is just a few from that report, but use cases include actually archiving software, referencing the archive software, working on citations, citation management, software citations in general for the purpose of credit, cataloging and browsing the development of software to understand how it's changed, actually publishing software, describing software, referencing, and then actually just using software as well. And this is 6 out of maybe 20 or so use cases that are in that longer report. And then we get into identifiers, and there's lots of different identifiers. So just as an example, there are DOIs and software heritage IDs that Matt discussed. There are arcs and handles that I think were in Ted's talk. There are ASCL IDs in astrophysics. There are HAL IDs for things that are created by people in France. There's Wikidata. There's RRIDs that I think Ted mentioned as well from the life sciences work. There's Git that Matt mentioned. There's SW Math IDs for math software. Right, so there's lots of different things, and they show up in lots of different places, but they're all used for software in one way or another. I was going to talk about this idea of intrinsic identifiers and use software heritage as an example, but Matt has kind of done that, so I'm not going to go through this in any detail other than saying the intrinsic identifier, as Matt mentioned, is intrinsic. It comes from the object itself. It doesn't have to do with where the object is stored or anything but its content. And then there's also extrinsic identifiers, and just using the HAL identifier as an example, if we imagine somebody that's a researcher that wants to submit some software into a repository, the HAL repository in this case, they submit that software along with a bunch of metadata. The software itself can be identified through potentially something like a software heritage ID, but the metadata is completely different, right? The metadata is not stored, at least in case of software, usually as part of the object. And so it is separate from the intrinsic identifier, and it is something that works much better with an extrinsic identifier. And so you imagine that somebody is actually then going to check to see if the software is there, check to see if the metadata is right, publish the metadata, and point to the object, potentially using the intrinsic identifier. And then somebody later can then actually reference it or archive it or get to it or something else. But if they want to cite it, they need the metadata. If they just want to use it or get it, they just need the intrinsic identifier. So there's kind of, again, these different purposes, and intrinsic and extrinsic, neither one necessarily is perfect, and combining them actually is kind of nice, but kind of difficult. There's also this fact that there's discipline-specific needs that have appeared, and in response, discipline-specific registries have appeared. So I mentioned astronomy, life sciences, and math, and they're here again. The purpose of these registries are to let the community register different types of objects, which include software, with an organization that curates them and understands the context in which they're used, the discipline in which they're used. And those entries then can be used in papers, including in citations. And so if you're working in a life science journal and you have an RRID for a software project, that's probably going to be fine. If you put in an RRID in a computer science journal, probably the reviewers are going to say, what is this? Can you just use a DOI instead? So different identifiers work better or worse in different contexts. And part of that is based on the disciplinary expectations. The other issue is that these identifiers are independent, but you can imagine software, let's say Matplotlib again, that's used in a bunch of different disciplines. So the registries can actually then have overlapping content. There can be an RRID for it, there can be an ASCL ID for it, there can be an SW Math ID for it, there can be a DOI for it, et cetera. And if we think about the intrinsic identifier that I mentioned before and Matt talked about, that can help say that these things are the same, but they may not all have the same metadata. So they may not all look identical at an extrinsic level or at a registry level. The other thing is there's also software papers. So if we look at the Journal of Open Source Software as an example, a research software package then is going to have an article ID that's basically the crossref DOI that points to the paper. And then there's also a software ID, which often is a DataCite DOI pointing to Zenodo or Figshare or HAL or something else. And so this then leads to two different DOIs effectively for the same idea. Not for the same thing, right? One's the paper and one's the software, but depending on what level you're looking at and what kind of granularity you're looking at, you may think of these as similar. So yeah, and so then these can also then link to the live version of the software, for example, on GitHub. And so then there may be a Git hash ID as well, potentially, or a GitHub URL. So just to kind of try to summarize this briefly, and again, this is in this report in much more detail. There's different levels of granularity. There's different types of extrinsic and intrinsic identifiers, and they all kind of work for particular things. And you could actually do a three-dimensional plot here as well and talk about different use cases, because those also are somewhat different. And so the result of this effectively is that, right, we don't have a good answer here, and this is really complex. And the reason it's complex is because software, I think, and we can argue about this, is inherently more complex than papers and data. Software means lots of different things, lots of different kinds of granularity, projects, source code, executables, papers about the software. The idea of permanent identifiers for software is newer than that for papers and for data. It's really the last 10 years, more or less, and more focused on the more recent part of that. And then finally, the software ecosystem doesn't have a natural need for a publisher entity. So by that, I mean that when you are publishing a paper or publishing data, you're giving it to a publisher or a repository along with the metadata, and that publisher is then actually making it available, making the metadata searchable, kind of worrying about things like that. But software is often identified through non-archival source code social coding platforms like GitHub. And then you don't really have metadata associated with it. And you've got lots of different versions that aren't necessarily very well linked. When you get into package management systems, you can actually kind of think of package management systems like publishers in some sense. And this actually helps a bit, but this isn't how a lot of software is distributed. And so then we get to the kind of bottom line to me, which is that we're not going to have a single type of permanent identifier, persistent identifier for software. So we have to figure out how to live with having a bunch of different ones. And some questions that I think about is, could we actually build some kind of a federation or an API layer that lets us actually just deal with this and hide some of the complexity in that in that layer from users. I just want to say one final thing, because as we're talking about different kind of organizations and different kinds of identifiers, I think it's important to think about how those identifiers are managed and how they're governed and how they're sustained. And so I just wanted to talk about POSI briefly, the principles of open scholarly infrastructure. POSI was intended originally to be a set of guidelines by which open scholarly infrastructure organizations and initiatives that support the research community can be run and sustained in an open way. And so this is a little bit of an anti-commercial rant for like the last 30 seconds. So I think when we look at different systems we're using, and the one that Ted mentioned in terms of credit, which I don't remember the name of, is one that I'm a little bit concerned with because It's not open, it's commercial. And whenever we start using commercial systems that we don't have any control of the governance over, there's a danger that those systems are going to go away or they're going to change once we become dependent on them. I'll just say this, the technical term for this is enshittification, which is kind of a weird term, but in any case. So think about what infrastructure you're using. Think about if it's actually signing up to POSI principles or some other open governance, sustainability, insurance principles, so that you know it's going to be around and what will happen if there are problems. Okay, with that I'll end, and hopefully we'll go on to some discussion. Thanks.
Thanks, Dan. So since Dan is online and not able to be tracked down in the halls, does anyone have questions for Dan? Oh yeah, got one online.
Actually created a question session on the online document, and they've directed questions at specific speakers as well.
Okay.
All right, so we have a question. Could the knowledge graph efforts be used to link between software PIDs to create a page for each item with a list of the associated PIDs? For example, a master DOI page per item.
Yeah, I think the answer is definitely yes, in theory. How complex that would be in practice and how practical, I don't really know. We've talked with, the knowledge graph people, whose name is escaping me for the second, the people within RDA, Scalix, about this. And they've been interested in adding software into Scalix, but we haven't really gone very far on that. And so if that happens, then I think what the question was suggesting would be kind of a consequence of that, that we would try to get into the detail of the software and start building up not just a knowledge graph that includes software, but one that includes the details of different software relationships as well.
All right, thanks, Dan. And great talk. I think it's very much complementary to the previous ones as well. So we're going to now go into breakouts shortly, but Mark's going to say a little bit first about some ESIP activities and kind of set the stage for that.
Yeah, I just wanted to give a little plug for the Research Artifact Citation Cluster, because that's who's sort of hosting this, as it were. We've been around for a while. Started out of the Stewardship Committee, where we published citation guidelines that were updated in 2019. Another cluster published software and service citation guidelines. And then those two groups sort of came together to look at the broader question of can we define general guidelines for citation of all research objects? And we have concluded no. We were hopeful, and we found that we really need to separate the multiple concerns of what we're trying to do with citation, like credit and access. And that work was summarized in a iPoster at AGU a few years back. And then we explored, under the leadership of Madison Langseth, we explored the issues of credit. That's a very complicated issue, goes well beyond identifiers because it's a human concern, so it's fuzzy and it's messy. And we summarized that in an EOS article published last year. So that's just a little plug for the cluster. If you're interested, there's our wiki site, and you're welcome to join. And Diana Ma, who's online, is our new lead. And with change in leadership, change in focus, we're moving on to this issue of what is how to use PIDs more generally. So we're really going beyond citation, looking at the variety of different things that we need to do with PIDs, as we just heard from the previous talks. And so one of the things that the cluster has done is we're really good at making matrices. And we've worked through a lot of matrices, and so we've by no means populated a are we good? No. Or is everybody just looking at Dan?
I'm just going to do desktop.
And so I'm sure you can't see this on the screen, but there is a link in the notes, so we're going to want to make use of this during the breakouts. So across the top, thanks. are a bunch of different kinds of what we're generally calling research artifacts. We don't call them research objects because that is a specific meaning in certain contexts. So it's, you know, it's publications, it's data, it's software, it's semantic artifacts, it's instruments, it's facilities, all these different things. This is a very long list. This came out of work from the cluster some years ago when we were looking at issues of reproducibility. It's probably too long, but these are the types of things that we need to identify in some context. Down the column 1 is the beginnings of some use cases or some goals. These come from RDA largely. The first set is from a group called the RDA Group on Persistent Identifier Types, specifically looking at use cases for data, but I think we could apply them to other objects as well. The second grouping is Dan's summary that you just saw of the lengthier thing that came from the RDA Force 11 software identifier group. So what we want you to do in the breakouts, we'll just break out into corners of the room here. And how many people do we have online, Daniel? Okay, so we'll break you all out into 2 groups too. And just get together in the group. There's if you go to the notes document, there's a link to a breakout template. Make a copy of that template so we're not all working in the same thing. And basically, yeah, we'll pull it up here. Basically, we want you to think about what are your use cases. You know, so look at them. You know, what are you trying to do with an identifier? In our previous talks, we heard a number of examples. Everything, you know, from high-level credit to specific, very granular level identification, you know, that you're using in your script. So spend about 15 minutes. We only have a little less than half an hour left. Maybe spend 10 minutes talking about these things that you want to do with identifiers. I think use case is a rather grand term, maybe goals. And then spend some time thinking about the attributes of these different persistent identifier systems that help realize these goals. So, you know, it could be, you know, the metadata schema associated with it. It could be, you know, the difference between intrinsic and extrinsic, or content-based or authority-based, depending on how you describe them. That sort of attribute, you know, it could be the trust that you have in the organization behind the authority. There's a variety of attributes of identifiers that we need to consider. And our goal is then this is going to be sort of action for the cluster going forward, where we can start mapping these attributes to these goals, and then begin to make some recommendations on what sort of identifiers or what sort of identifier systems to use for what sort of objects and concerns. So does that make sense as a goal? Any questions on that? Okay, so why don't you all just, you know, cluster over there, cluster over there, cluster up here, and Dan will fling people into random virtual groups. So you want to go?
We can just split up.
One thing I just wanted to mention, just to make sure it's clear, and Dan said it in his talk, but these different kinds of identifiers that we're talking about are not mutually exclusive. Okay, so the metadata for DOIs, for instance, the data site includes other identifiers, which could be intrinsic ones. So that's an important point. I think it's not either or, it's both.
Yeah, it's a collection. All right, Matt's going to host a group over here. Matt Jones is going to host a group in the back corner. Ted Haberman's going to host a group in that back corner, and I'm going to host a group up here. Gather tightly. Hello? All right, folks. Thank you all. You're all still deep in conversation. That's a good sign. We're out of time, but I just want to go through each group and just see if anybody wants, did you have a big aha moment or a takeaway or a key suggestion for what's next for the cluster? Maybe I'll start with the back right. Anybody in that group want to chime in?
Yeah, Ted just moves out.
I don't think we had a lot of big ahas. One thing we found, sort of the idea of differences between collections and granules. And we had a couple of situations, both the Arctic Data Center and also NASA, who use DOI sort of at the collection level, and then UUIDs or something like that at the granule level. And the granule level is really where the kind of stuff, the intrinsic identifiers that Matt was talking about. So Jeanette from the Arctic Data Center was there and talking about, accessing files through identifiers. And then we talked a little bit about projects in having DOIs for projects and all those different resource types that are in DataCite. There's some of them that shouldn't change when they get a DOI. And then there's some things like data sets, that is. And also, but then things like projects could change as a function of time, and other things, data management plans might change as a function of time. So the DOI points to something that's not necessarily immutable. And we understand that identifying everything is important so that you can connect it. And so if it has a DOI, it cannot change statement maybe only applies to some of those resource types in DataCite. Oh, and there was a comment about one system for all or something, I guess, in the document. And really the one system that we have for all is really handles. And DOIs, ARCs, and Orchids, and IGSNs, for instance, are all handles underneath. So that's really, I would say, the foundation system that we build in some case, object-specific metadata schema on top of.
So them's fighting words for the ARCs community. I would say URIs are perhaps the system that is for all at some level. But let's not go down this path. No. Yes, I know. Orchids are handles too. Yeah. Anyway, does someone from this group want to summarize?
So we talked about various use cases and the different groups that have different identifiers, and they sort of promoting and using different ones. And in the technical, sort of people that are dealing with this knowledge graphs, and they want more and more identifiers, but the people that have to sort of deal with the people that are going to be creating the content and the identifiers themselves, sort of the social issue of getting people to identify their objects is a very difficult problem. And if we're proliferating more and more, maybe that makes it, sort of more difficult. We want more to do our work, but getting people to label it is sort of one of the hard problems that maybe needs to be focused on too.
How about online? Anybody do they have speaking access? One of the groups online want to chime in?
Can you hear me?
Yep.
Okay. Yeah. So I was just gonna say, yeah, our group had a pretty good discussion. Some of the things that we learned, or well, software citation and identification is really hard. A lot of people are thinking about that. So DOI infrastructure, I guess somebody's working on this, but it's interesting to note, DOI infrastructure overrides content negotiation. So the example that was given is that Pangea uses DOIs, and if you request an RDF representation, if you request a data set, you're going to be directed to DataCite, and DataCite hosts an abridged version of that data as versus the original large data set. So you need to know to go back to the Pangea server to get the original large data set. Otherwise, you're going to have an abridged version of the data. And so there are existing challenges with large data sets, citing large data sets or complex data sets, which I believe there's an RDA group that works on that, which I'm trying to hook up with and would love to learn more. Content-based identifiers can be sometimes difficult to discover. So the question is, should multiple citation systems be used? It may be confusing to users or researchers who want to know how many times research is cited. One potential solution would be to have the systems redirect to each other, but that's done manually sometimes, which is really labor intensive.
Okay. Yeah, the point that a nice attribute of a persistent identifier would be to allow content negotiation. How about the other online group? You know, they may have all checked out. Are they there?
No, well, we can close it up.
Okay. I will just say for our group that I thought was really interesting is that there's a need for sometimes for identifying concepts, which may then have various subunits. The example that Leslie gave was a broad concept of a particular model, which has many different versions, configurations, uses, code instantiations, et cetera. And the other was managing change, particularly when, like in an organizational context where things reorganize. So being able to track how an entity has changed. So that, you know, subunit A and subunit B merged, but they excluded a certain portion, something like that. So that was an interesting attribute that we hadn't thought about. You want to chime in?
Well, just note, I think Karen started off with a discussion or comment about the tension between citation, sort of credit things, and reproducibility. And I think that kind of led us into a really interesting discussion that it's difficult to do both of those things, and the PIDs don't help you. Doesn't make it easier to do both of those things because they're kind of at odds in some sense of what you're trying to do. So we had some good discussion of that. But I think with that, let's close the session, since at least for the folks here, we're at lunch. And thanks to everyone online. Thanks, Dan, if you're still on. He may not be. And all the speakers, and more discussion at lunch.
And join the cluster.